So, ladies and gentlemen, let's give a warm welcome to Ben Ilegbodu.
Thank you very much. All right, so yes, my name is Ben Ilegbodu. Ben, my namesake, did a pretty good job of getting my last name, so I'm pretty impressed there. So I'm here to talk about, the title is Isomorphic React Without Node, and how we accomplish that here at Eventbrite. I've posted a link to my slides here on my Twitter account @BenMVP. So if you want to go to my profile, check out those the slides, you can follow along. I'm going to have lots of links inside of the presentation as well, so you might want to follow up that way. But just a heads up there. And let's go ahead and get started. So first, let me kind of just set the groundworks, what this talk is not about. Since this is a React meetup, I'm assuming that most of you guys know React already, hopefully. I don't have time to go over it anyway, so I'm assuming that you already know how to use React, or why to use React, how to build with React. And I'm not going to go any kind of implementation details of how we built and architected what we did, because it'll take us all in the weeds, and we don't want to go there. But instead, what I am going to talk about is this concept of isomorphic React, and then without a node web server. So isomorphic React, for those people who don't know what it means, it essentially means taking the templates or the components that you render on the client side and also rendering them on the server side. The same exact templates, so that you don't have to duplicate what you're doing on the server side with the client side. So I'm going to talk a little bit about that, and then kind of the overarching architectural design of what we built to accomplish this goal. So to be honest, it really shouldn't be called isomorphic JavaScript or isomorphic React. It should be called universal JavaScript or universal React, because isomorphic doesn't actually mean what we are using it as. Isomorphic basically means that there's something that looks the same, but underneath works differently, whereas universal means that it works everywhere. So we really should be calling it universal React. I should be calling it universal React, but I still call it isomorphic React, because in my mind it sounds cooler, you know? And I think I sound smarter by saying isomorphic React. I implemented it in isomorphic React. And it's like, you know, if I put that on my resume, like that's a keyword, right, for them to search. So I'm gonna stick with isomorphic React. I suggest you too, but I won't be mad at you if you use universal React. So a little bit about myself. Like I said, I'm Ben Ilegbodu. I'm a Christian, a husband, and a father. This is my wife, Rashida, and we've been married for 6 years, a little over 6 years. These are our two daughters. Our oldest, Simone, is 2.5 years old. Our youngest, Avery, is not even 2 months old yet, so we just had her. So oh, wow, thank you. Thank you very much. You really should be clapping for my wife, but I'll take the congratulations. But at any time during this talk, you catch me yawning, you know why I'm yawning, okay? And so I work for Eventbrite, this wonderful place that has hosted us here, and I'm on our front-end platform team, and actually just recently became the manager of our front-end platform team, so exciting times going on. Ooh, more claps, okay. How many times can I get applause during this talk? Okay. But what our main project that we've been working on this last year is building up a React stack, a whole new React stack, transitioning from our backbone marionette to React. And one of the qualities of this stack is that it had to be isomorphic. It had to be able to render on the server, because we needed to have improved performance in SEO. And the performance benefit comes from rendering on the server side. The page will actually render quicker because all of the content is already there. You don't have to wait for your JavaScript to download and then for it to re-render on the client side. It's already rendered server side. And then as a result, Google, and probably most of the other search engines, because they just copy Google, is that they factor in the rendering speed into their algorithm for search. So if your page renders faster, it's actually going to go higher up on their search results. So isomorphic React was really important, especially for key portions of our page, like search results or our main event page. But unlike other JavaScript frameworks, React is actually built to be able to render server side. And as we know, in order to render or to execute JavaScript, you need a node interpreter because we need to be able to interpret JavaScript fully. And typically with a universal React or isomorphic React application, you will have a Node Express web server that will be taking in all the inbound requests, and then using something like React Router or some other routing library, you would then go to the specific page and you would render it that way. And then using React's render to server functionality, you would take your components, render them out to a string, and then that string would go in the response that you return back from your Node Express server. But since Eventbrite has actually been around for about a decade, I think we just celebrated 10 years earlier this year, our backend isn't in Node. Our backend is actually in Python and Django. So obviously Python Django can interpret JavaScript. So the question is, how do we, with a backend, a middle tier that is Python and Django, how do we render React components? Actually, anybody else on Python Django? Any other Python Django folks? Only 3 or 4? Okay. Okay, that's fine. I'm not offended. But the way we solve this problem currently with this kind of dual rendering issue in Backbone and Marionette, it uses handlebar templates. So what we did is we found this library called PyBars, the combination of Python and handlebars, PyBars, and it would take the handlebars template and render it server-side. So pretty much exactly what handlebars does in the JavaScript to create JavaScript functions that create a string, there is a Python version of that. Except the Python version was super duper slow because I guess whoever wrote it didn't know what they were doing. So hopefully the person who didn't write it is not here. Hopefully not. I'm sorry that I offended you. But the same solution wouldn't work for our React components because, as you know, we need a JavaScript interpreter. And if we were trying to do the same solution in Python, we'd essentially be recreating Node in Python. And we did kind of think about that for 2 seconds, but then decided that that was not the proper way to go. But this problem is not just for Python and Django. This problem is also for if you have a Ruby on Rails backend. Anybody on Ruby on Rails developing on that? Okay, more folks. How about PHP? Who's using PHP? Okay, somebody give me like a, what does that mean? Kinda, sorta, sometimes. You just don't feel that great about it? Okay, anyway, what about .NET, ASP.NET? Anybody with a .NET? We got a couple of folks, .NET folks, Microsoft, okay, cool. Java or Groovy, anything on the JVM? Okay, few people. How about Cold Fusion? Anybody doing Cold Fusion? No hands? I'm sure if you were using it, you'd probably be too embarrassed to say that you're using it anyway. But people still develop it. I see CFM on websites sometimes. So over the past times, we've been trying really hard as a front-end team to pitch, hey, let's just transition our web server to Node. And every time ops is like, no, don't do it, right? And not because Node is bad or anything like that. It's just unfamiliar to our ops team. You know, we are familiar with Node as a front-end team because we're used to NPM installing every day, removing all of our Node modules and NPM installing every day, right? But they are not familiar with it, and they actually have to manage the Node server when it goes down. You know, I don't want to be called in 2 in the morning because the Node server went down. I want them to be called, and I want them to know what to do with it and how to monitor it and how to log it and stuff like that. So basically, and then the other problem actually is that our web server is still kind of that big ball of mud type of application. You know, we're getting better with services. We're factoring things out to services and being service-oriented architecture, rather. But it's a long process, and we have a lot of legacy logic in our middle tier. And if we were to transition to Node, right, and have a Node web server, we'd have to move all of that legacy stuff, which we really wouldn't want to do. And matter of fact, us transitioning our front end to React was already kind of a big gamble in itself, trying to tack on moving the whole web server to Node would just been something, they would just kept saying no, just like that little poor baby who's just trying to get that glass of water. Poor baby. So we were in this dilemma. What do we do, right? Our web server cannot change from being Django, right? That's a must. But on the other hand, we need a Node to render our JavaScript components on the server side. And we're all confused. What do we do? And the answer was that we just had both servers. We had a Node, we still had our Django web server, and we had a Node web server. But in actuality, the Node web server was really tiny because it was more like a service, and it was a rendering service. The service, all it did was take a component and render out that component and return HTML. That's all it did. And what I'm going to do is kind of walk through the architecture using some pseudo-code-ish type thing to show you kind of how we put it all together. Okay. So what we created was what I'm calling a stateless render server, React render server. So it had an endpoint, but that endpoint was off localhost, so it wasn't publicly accessible, only private, only to the machine that it was sitting on. So localhost 9009/render. And then what you pass to this server was the path to the component that you want to render. And then you would pass in the props that that component needed in order to render. And you have to pass in all of the props that it needs for it. Everything must be passed in to it. So it can't make any AJAX calls. It can't access your MySQL database. It can't look in the environment to know what language you are in or any other context stuff. Everything has to be passed into it. So it's stateless. I call it stateless because it still had access to the file system, which is where all of the components lived. So it's not truly stateless, but for the most part, all intents and purposes, it is stateless. So if we had this, let's say we had this React component here. It's a hello world component, and it's actually a stateless component in React. That's interesting. That was on accident, but that worked. So it takes in this prop that is name, and then it renders out a div that is hello, and then the prop name in there with the exclamation at the end. The exclamation point is key. So if we were trying to test out this service and trying to hit the endpoint, we would make this curl request. And the curl request hits that endpoint that I said, localhost 9009/render, and it would make a post. And it would post it JSON, and that JSON would contain the properties of the JSON would be the path to the component, the absolute path on the server, as well as whatever props need to be rendered. So in this example, the path is the path to that hello world JSX, and then the props are the name, and then I passed in bin. So it says hello bin as the response to the curl request. That's what you get back, just the markup. That's all I returned. So here's kind of a high level of the Express server, the actual render server here. So it has a route that is the /render route right there. And then it reads in the request that was passed in. So the request body is the JSON, so we parse that out. And now what we do here is we require the path that was passed in. It's a dynamic require. So normally you would do require Express or require React or require some other library. We're dynamically requiring the component. And as a result, we have a reference to the component class right there, dynamically. And now with that reference to the component class, we can pass that to react.createElement. And react.createElement takes a component class and then the props that you want to create that element with. So now we've created a configured element from the component plus props. And now we have that element. And then lastly, we pass that to React DOM server.render to string. That's kind of the magic of all of this, is that it can render an element out to a string just for us. Because React is this just a composable amount of components, it can be easily rendered out to a string, which React already provides a mechanism for. And then lastly, of course, we take that string of markup way down here that I don't think anybody can see, unfortunately. But it says we're just basically sending that markup as the response body. So that gets returned. So obviously, the actual server was much more complicated than this. There were way more implementation details, but that's kind of the high-level thing. So in order to run this server, you would just call node and then the server.js, and you would run it. That's basically the simple way that the base running of the server. And since it has the verbose, it would tell you when it started and that it started the server at that port. And then if somebody made that curl request that we saw earlier, it would then have this log that would say there was a request for hello world.jsx. And that's basically how running the server would work. So then we had this service. It was there. It was working. It will return the response with the component HTML. The next part was the Django side, the middle tier, to connect to that service. So first thing we had to do was create the props that we're going to pass through to the component. So that means we have to make all of the DB calls that we want up front, all of the SOA calls up front, process anything that was passed from the GET request, anything from post, any environment like the language or the language context, put that all into this Python object called component props, and then now make the request, the post request to the server. So then as you can see, similar to the curl request, we would go to the render server URL, we would pass in JSON, which this would be encoded as, and then we would get back the response Python object. And then response.text and the Python object would be the actual markup. And then we put that markup in the template context, basically, as a variable called React page markup. And then that variable ends up being able to be used in an HTML template. Now, this HTML template is our templating language that we use with Django. It's called Mako. And we are trying to avoid having to use server-side templating at all, but you have to have some kind of scaffolding HTML for the page. So creating the HTML tag, the head tag, whatever you want to put in there. But essentially, we would take all of the markup and put it right there. So the whole rendered page that was rendered in React would go inside of that div. And then the script tag below is obviously the bundle.js that includes all of the React.js stuff we needed. So at Eventbrite, we have basically a series of single-page applications, like different sections of the site are their own single-page application. So the template was a little bit more complicated than this, but this was kind of the basic outline of what we would do. So we still had a little bit in the middle tier for templating, but the heavy lifting was still done inside of React. So then the question some of you, I hope, are thinking is, isn't there a lot of network overhead with doing this, going out to the node React render server service and coming back? And the answer, of course, unfortunately, is yes, there is overhead to make that network request and come back. But I think that is mitigated by a couple of factors. The first is that we put the Django server as well as the React server on the same machine. So there's only so far that the electrons have to go back and forth, right? They're on the same machine. And then secondly, what we did is we try to enforce that we're only going to render we're only going to make one call to the React render server per page render. So what we try to do is render a whole React page instead of trying to render different pieces of components that make up a page. So there's a one-to-one mapping between renders, so there's less round trips that are happening. And then the last thing that we found out, which was actually, I guess, serendipitous, is that rendering in the node render was significantly faster than PyBar's rendering. So that bad library that I talked about, which was 10x slower than rendering in Mako, was actually much slower than rendering with Node. So making the round trip to the node service, rendering on node, coming back was actually faster than using the PyBars library that we're using. So in the end, transitioning to React ended up rendering the page faster than before, which was great. So that was on accident, and it was actually helped push this project forward because I was worried that it was going to be much slower and we'd have to do all these optimizations, but thankfully it actually ended up a lot faster in that regard. Okay, so that's basically the high-level overview of it. That's kind of how all the pieces work. That's it. So hopefully if you guys are in a similar situation, what I've described so far is compelling. No doubt you have your own legacy code that you'll have to deal with, so the implementation details will be different. But now I wanted to take some time to kind of highlight some gotchas or some pitfalls that you can swing over so that if you run into it, then you will know what we already did to try to solve those problems. So the first thing was we needed to transpile on demand in dev. So if you remember, this is how we ran the node server before. And the problem that we're trying to tackle is that we don't want to have to compile our JavaScript manually every time you make a change in order to run the server. We want it to be able to transpile dynamically. So every time we make a change, it would transpile our JSX back to native JavaScript and our ES6 back to native JavaScript as well. So if we didn't do it, if we just ran the server normally and hit it, we would actually get an error like this saying that there was an unexpected reserved word import because it doesn't know the import statement. So what I tried at first was, let me just use Babel node instead of regular node. And Babel node is this alternate CLI that Babel put out that wraps node. And basically all it does is it just transpiles everything that comes in that gets required up front. And it's only supposed to be used in dev because it has a huge memory overhead and things like that. But since I only wanted to use it in dev, that shouldn't have been a problem. And actually, it worked pretty well. So when so in that code that was dynamically requiring the component and all its dependencies, everything got transpiled correctly and the request worked. But unfortunately, with the next problem that I was trying to solve, Babel node turned out to not be the right solution. But let me talk about this solution first. So the other issue is that when you make a change in dev, you don't want to have to restart the server, because when you do require, as we can see up here, the component gets cached by node. So every time you make a require for the same thing again, node doesn't go back to the file system and process it and interpret it and give you the object. It has it in the cache. Well, this was a problem for us because we made a change to hello world.jsx and the server had already cached it. So I'd have to kill the server and then restart it in order to be able to see the changes, which obviously is annoying. So there's a package called Node Supervisor. I got a link to it way down there. Node Supervisor that will basically do that for me. So you pass it this watch attribute there. I say I want to watch everything in the JS React folder and only JSX extensions. And when anything in that file changes, what it will do is it'll crash the server basically and then restart it. But the problem is that when I did that with Babel node, when it was crashing Babel node and trying to restart it, I got this error, this address in use error, except it says EADDR in use, and I had to Google what that was first. But that was an error, address in use error. And I couldn't figure out what was going on, why this was a problem. So, I started pulling my hair out, and that's why I'm bald now, because of this problem. But ultimately, I figured it out. And the issue was Babel node itself. So instead, I had to use this require property or attribute that you can run on the regular node CLI. And what it does is you can give it a separated list of packages or node modules that you want it to require before it actually runs your script. So in this case, I'm telling it I want it to run this Babel register node module before it runs my server.js script. And what Babel register does, it's a register hook that Babel released as well, so that whenever anything is required, it will automatically be transpiled. So it sounds exactly like how Babel node works, except it worked a little bit differently because it actually did work with node supervisor. It would restart successfully and start the process over. So if you find yourself in this situation, just use Babel register. It only works for node 4 and higher. So if you're using node .12 or anything other than that or lower, you won't be able to use this solution, but you have it there. So, but then I ran into another problem with this, is that I developed it on my local Mac and everything worked fine. And then I pushed it to our Docker environment, which runs in Vagrant, and everything was not fine. When I made changes to the files, the server didn't restart when I expected it to restart. So the problem ended up being that Docker Vagrant is an NFS file system, and the NFS file system doesn't work with the same file change events that were firing that Node Supervisor was expecting to be fired. So the result was that I just had to do long polling, and I did a long polling of 5 seconds. So basically every 5 seconds, it would go through the whole directory tree, see if anything had changed from before, and then if it had restarted. And that was unfortunately an unfortunate side effect or problem, because now as you're developing, you would click save, refresh the browser, and it wouldn't update. Then you refresh the browser again, it wouldn't update. And you never know, it's not deterministic of when it's gonna update. So it's kind of a suboptimal developer experience, but this is all we could do for now. But our backend platform team is actually transitioning us from Docker Vagrant to something called Docker Machine, which is something different. And supposedly it supports the file system event notification. So this hopefully will be fixed soon. Okay, another problem that we had was our node modules wait. So our front end is running, our dependency system on the front end is require.js. Is anybody else using require.js on the front end for their dependency management? Okay, not too many, that's a good thing. So require.js, since we're using it, we would, on our build machine, build up all of the app bundles that we needed for each individual page and pass that to the actual production machine. And as a result, our production machines never needed node modules folders on them because we never were doing anything server-side, so they never needed them. But now that we were trying to do stuff server-side, we needed those node modules that weren't there, so the server didn't work once we went to QA, rather. So my first guess was like, okay, let's just make sure we copy the node modules folders over from the build machine to the production machine. And it turned out that it added an entire gig or more to the tarball that's getting copied over, which is crazy, right? A whole gig just of JavaScript dependencies, that's madness. But the thing is, our package.json has like 75 plus things in there. Like 50% of it, we don't even know what they're doing, but we're afraid to remove them and break our website. So, and most of them we weren't going to be using server-side anyway, because like I said, they were legacy. So once I did that, I made that change, ops sends me a Slack message and is like, what's going on? It's taking the build machine X number of minutes more to copy this stuff over because it's an entire gig. So in the end, what I had to do was whitelist what would be copied over. So only the node modules that we were going to be using on the server side, we copied over, and the ones that we weren't, the majority, didn't get copied over. So because we were on NPM 2, and because we have those dependencies of dependencies of dependencies, which are all duplicated, that's why the file system was so big. So the whitelist solved that problem, but then there's always this case where somebody adds something on dev and it works, and they forgot to put in the whitelist, and then it doesn't work on QA server, and all that back and forth. That continues to happen. But once we transition to NPM 3, or we decide to forgo NPM and use the new Yarn that came out last week, Those have flattened dependency trees and deduping, so hopefully the node module won't be that big. Maybe it'll be, I don't know, 250 megabytes, 100 megabytes, something like that. That's a little more manageable so that we don't have to worry about whitelisting anymore. Okay, so I took it so far, I built the proof of concept. I was actually able to get it onto QA, but for it to be production ready, we needed monitoring and logging. And so I'm a UI engineer. Like all I just showed you was already like 2 steps past what I thought my capabilities were, right? But now trying to add logging and monitoring, like I would talk to people and they're saying we have graphite and Grafana and we have to put stuff in Sentry and like all these like terms. I was like, I've heard people say them, but I don't know what they mean or what they are. So this is where I kind of handed off the baton to some back-end engineers who are way more capable, who are super helpful. And what they ended up implementing, and this is why it's in bullet points and not code, because I didn't implement it, is that we added a ping health checkpoint. So you could just ping the server to know, and it would just respond and say, I'm up. So that was something. We added log file writing with this node bunion package, so we could write any errors or any verbose logging to that log file. We did Sentry error logging with Raven node and Bunion Centrum stream so that we can know when errors happen, because our backend errors were already in Sentry, so we wanted those there. And then we did performance logging so we could know how the rendering we're doing over time. And our ops team actually did some great load testing. What happens if 1,000 users are using this thing at the same time? How many node servers do we need to be able to handle that and so forth? So we're able to do all that stuff. Everything seemed to pass really well. And it's running in QA. We have a couple of features that are being developed actively right now that are in QA. So we're getting there. Nothing in production yet, but that's basically more so because the features aren't ready to go production because they're new, not because the product isn't ready or the service isn't ready. Okay, so wrapping up. I have some additional resources here if you want. So apparently at the same time that we were building this React render server, Airbnb was building something that they called Hypernova. And they open sourced it at the end of May, and it does essentially the exact same thing that what I described to you. When we were looking in January for something, we didn't find anything because they hadn't open sourced it yet. But if you're a Rails system, they have a lot of helpers, little middle tier logic for Rails. So I would suggest giving them a try. They have a lot of, they added something additional to what we don't have yet, which is this virtual environment so that globals won't leak between different requests. So it's a pretty cool implementation. But if you want to build yours in Python, for instance, these are the libraries that we used to build this system, helper libraries. There is react.js.net that helps for rendering React components server side. So if you're on .NET, that's a cool package to look at. And then if you are on the JVM, there's this project called Nashorn that allows you that has a JavaScript interpreter in the JVM. So you might want to check those out. All right. So just to close, I wanted to give some shout outs to folks. I wanted to shout out Real World React for having me here, for allowing me to share with you guys. I don't know if you realize it here, but we're super privileged to have these meetups that happen like every week that we can go to. I get to speak in other parts of the country, smaller cities at their conferences, and like that conference is literally the only thing they have the whole year. And yet here we are, having conferences every month, meetups every week, workshops that we have. So we are super privileged, and it's all thanks to a lot of the hard work of organizers like Ben, who put these kind of things together. And I'm sure that folks like Ben, who put these things together and have to do all these work, don't get the thanks that they deserve. So Ben, I wanted to tell you that I really appreciate what you're doing, and I wanted to take time for everybody here also to appreciate you. So let's give Ben a round of applause for his work. It's a lot of effort that way. So yeah, thank you very much. Also wanted to thank Eventbrite for hosting, right, and providing the food and the drinks that we could have here. And specifically here at Eventbrite, I wanted to shout out Hillary, who I don't, oh, Hillary is way back there probably doing some work or something like that. So a shout out to Hillary. A funny story about Hillary, or this is actually anyway, so about Hillary and our HR team. So they go to all these conferences, right? And they meet all of these people. So they get to hear all of these buzzwords. Like they hear React, they hear Django, they hear Python, all these stuff. But they don't know exactly how it all goes together, right? So if you were to go up to them and say, hey, how is Eventbrite put together? Like, what is the tech stack? She'll probably say something like, you know, you take Python, you take a little bit of React, and presto Django, eventbrite.com, you know? It's funny how that works that way. But Eventbrite is also a great place to work. It's not just ticketing an event platform, it's also an engineering company. I would say that engineering is the best department here. I don't see anybody else not from engineering. Yeah, so engineering is the best department here to work for. And we have a number of engineers here, I believe. So if you're from Eventbrite Engineering, raise your hand. Raise your hand. Yeah, we have a couple of folks. So if you're interested in knowing more about Eventbrite and what it's like to work here and develop and solve cool problems like this, find those people. It'll be the people who are smiling for sure. So just find them. And then lastly, I wanted to thank you guys for coming to hear me talk. Like I know for real, like you came to hear Tom from Facebook, right? You didn't really actually come here for me, but you didn't come late, so I really do appreciate that you came here. Although now that I think about it, it was probably because the food and drink were here earlier. But anyway, I still appreciate you guys listening, and I hope that I was able to share kind of what we went through. You were able to learn some things that you could be able to hopefully apply in your situation. And even if not, you just kind of have learned more about what it's like to kind of build these kind of systems. And with that, I'm all done. Thank you, guys. So I believe we have time for questions. So if anybody has some questions, I can answer it. So the question is how we go about gathering all of them?
Or what was your methodology for deciding, like, here's when I want to start front-loading these props versus, down the line when I want to front-load those props?
Okay. If I understand, I mean, basically we wanted the React server to be stateless. So in order for the component that was going to be rendered on the server side to be able to render, we needed to be able to gather everything up front on the server side. So before making the request, we had to gather everything that was there. So we had to make all the requests and all the DB requests as well as all the SOA requests to be able to gather the data, formulate it in whatever way it needs to be in order to pass it to the component.
So why did you guys decide to do server-side rendering?
I don't know who's.
Oh, sorry.
Oh, sorry. Okay.
Because I don't know. I've read articles that Google can parse the JavaScript.
Yep.
They run that and
Yep.
Can do the SEO on that.
Yep.
Have you noticed any improvement in SEO, or what's the improvement in render time?
Yeah, you're totally right, because I actually did a test to prove that exact case that Google can find something that's rendered completely on the server side, or on the client side rather. But Google has specifically said that rendering time factors into their algorithm for boosting performance. So it's kind of this, I mean, SEO in general is like this gray area. There's like no exact science to it, but we felt that we had to continue to render server side for that fact, because SEO is a big component of the traffic that we get that's just organic. So that was kind of one of the prerequisites for being able to transition over, was that we were still going to be able to do it without having to duplicate our templates. Yeah.
Comment on speed.
Yes, Google is not the only one, but it tends to be the one we end up paying most attention to. Do you work at Yahoo or something? No. Oh, okay.
And speed, is there any benchmarks you did before and after on rendering time?
Yeah, so I did a comparison actually we did a load test of the current event page, which uses the PyBars stuff that I was talking about, so rendering processing the handle wash template on the server side with a kind of trimmed down version of it in React. Made all the same DB calls and stuff like that, but rendered out majority of what's still there. And it was, trying to remember what it was, but it was probably like 30% faster. And I think that's attributed to how bad PyBars was, not necessarily that React was just like, or rendering on React was that much faster, but that was kind of the comparison. If we didn't have that part, I'm not sure what the delta would be, but I would say it would be even, if not a little bit better. That would be my guess.
Thank you.
Yep, you're welcome. Okay, you also get a USB charger. There you go. Okay, who's next?
Me.
Oh yeah, okay.
Right, so thanks for the talk. It was really interesting.
Yep.
So now that we're talking about like performance and like reducing initial payload time, have you guys considered or implemented some kind of like bundle or code splitting in order to not, download the whole bundle and parsing and have all these problems?
Yeah, so you're talking about on our actual web page not having all of the bundled JS on that page is what you're asking?
Yeah, and then just dynamically download them and execute on them while you're navigating.
Right.
Try to like.
So we only bundle the JavaScript that the page is actually going to use. So we statically determine, we have basically a client entry point, and that requires all the different dependencies that it needs going down the tree. So from that client entry point, we're able to figure out what all the dependencies are and then make a bundle that's only used for that page. And since most of Eventbrite isn't a single page app, every page is a new request anyway. We haven't needed that yet, but we're trying to move towards a single page app application. Then we're gonna have to do more stuff like that. But required JS doesn't lend itself well to that. So we'd have to transition.
Thanks.
Yeah, yep. Okay, you also get a charger. Yeah, thank you for your question. Okay.
Are you guys using any libraries to handle state in the React side of things?
Like Redux?
Redux, Flux.
Yes, so we are using Redux as well. We're using Redux and using Redux forms specifically because there's a lot of forms that we're processing. But we're not mandating that everything use Redux because there are some pages that are simple enough that the actual application state is a couple of collections of data. So we just kind of keep that at a top level app container. Basically, we're trying to take the principles from Redux, have an app container that has that state, and then manipulate it as things happen. So we kind of make as many things just presentational components and then just have one app that maintains it. But the second that we need multiple different components triggering state changes or the state gets too complicated and things like that, then we migrate to Redux. Yeah, okay. Okay, and you get the last one. It's not in a box, unfortunately. It was the demo version, but hopefully it still works. Okay, next question. Yes.
Hi. Thank you for the talk.
Yeah.
My name is Valerie, and I just graduated from App Academy.
Okay.
And so I apologize in advance if this is a new question.
No problem.
So I have two parts. First one, I wanted to ask, like, how long did this whole transition take, and which part was the hardest for you guys to figure out how to move on?
Okay.
And the second part of the question is, it seems like a lot of it is like you guys just jump into the question, you're jumping to the problem, and then not knowing what's gonna go on, and you like hit the problem and then you solve it.
Yeah.
Is it a really common pattern in the industry to kind of like feels like you're inventing the wheel on your own? Like, is there no other company that has like Python, Django backend and trying to solve similar problems? And how do you share information or knowledge?
Okay. Yes, I'll jump on that second one. So that was what we were trying to do first. Was somebody else had to have needed this problem before, right? And solved it, but we couldn't find anything. Like I said, later we found out about Hypernova, and had we started 4 or 5 months later, we probably would have tried to leverage that and just made the Django part to connect to the server that they have, since they wrote theirs in Ruby. But this is kind of the knowledge sharing that we need across different companies. So We were planning to open source what we've built so far. Now that Airbnb has a Hypernova, maybe we won't. It's still up in the air, kind of what we're going to decide to do. But when it was a lot of, for me, it was a lot of figuring it out as I go, because like I said, this wasn't my domain of expertise going into it. So I had to learn about how Docker works, how Node works, how Express servers work. Like I had never built anything of substance before. So a lot of it was learning in that regard. But I would say in general, that's not the case. Usually I already have some expertise to kind of piggyback on and to know how to apply it. But in this case, not necessarily. And then your first question was, how long did it take, the transition? So we're not like completely transitioned over to React. That's like, I would say getting completely off Backbone and Marionette is like a pipe dream. Not a pipe dream, I don't want to say it that bad. It's not that bad. But it's gonna take us a while to get rid of all the legacy code, I would say. So what we did first was build up the new stack, and that was kind of what we focused on, and we've been doing it. Now is October. We've been doing it for maybe 6 or 7 months, and there is some scope creep in the project, and we did some other things. We made a very cool design system that's also built on React as well in the process of it, so that's happened. But what we're planning to do, our kind of roadmap for transition is anything new is gonna be built on the new platform, so we're not creating instant technical debt, right? And then anything that is planning to be rebuilt in the next year, we also will just leave it as B, and then they'll rebuild it in React. And then anything super old is what we need to start tackling and converting manually over, because it's hard for me to go up to our VP of engineering. He's not here, yes, okay. So it's hard for me to go up to him and say, hey, we just need to transition the whole site over to React. He would just shoot me down like without question. So usually it has to be a new feature. There has to be some value attached to actually rebuilding it in React. So that's kind of how we're tackling it.
Okay, so we have time for 2 more questions.
2 more questions. Okay, you've got the mic, so yes. Oh, you gotta turn your mic on though.
Hello.
Yeah.
Yeah, so I have a question. So you have a situation where you have the Django server talk to the local Node.js server, but the Node.js server can restart intermittently whenever you push out a new updated widget. So I guess my question is, do you guys have a way to handle it if the Node.js server is rebooting when the Django server gets a request from the user, or perhaps what it is when it's in production, you guys just push out, you only deploy when you have a new release, and it just stays there and doesn't change until the next release.
Right. So the rebooting stuff I talked about was only in the development environment. So we don't reboot on production. It's just they're always running, unless it like died for some other reason, and then we have supervisor that will bring it back up. But when we deploy to production, it's just running, and then when files change, we take down all the servers and bring them all back up. So that's not a problem. But what you described is a problem in our development environment, in that we could be making a request from Django to the Node server, and the Node server is in the reboot mode. So we just see a temporal error on the Django side that says, I couldn't connect to the Node server, and then you refresh again, and then it's there again. So that is, as I'm sure as more and more people start developing on it and more of them start complaining to me, I'll have to figure out a better solution for that. But for now, that's kind of what we've gone through.
Was there any reason why did you prefer the web server over invoking through the command line interface of the Node? So instead of like hitting the HTTP request, you could invoke Node locally using CLI.
So we did think about that, like having a V8 in process thing that we'd have to execute. But we found that for ops to have to maintain something like that, that would be even something more different than what they are. Having a Node server, even though they weren't used to Node at the time, now they're more familiar with it. That's something that they're more familiar with. So I think that just was as a matter of familiarity in that regard. Cool. I guess that's it.
Yeah, how about another round of applause for Ben?
Thank you very much.
Thank you.